Hi, it's Gadget UK here again. Another short video. Right now I'm looking at another SIMM. So this is one of the ones I think that came from Cathers. In the previous part we fixed another SIMM, we identified which chip it was. But you could use RAM testing software on a PC to identify, which data bit is the problem, and then, by connectivity testing, look at the pin out there for a 72-pin SIMM or a 30-pin SIMM, if that's what you're looking at, and actually trace the data bit in question to the specific chip. And it says they're intermittent. We've got a chip taped on there. I think I removed that one because I thought that was a good one, sorry, a bad one, and it wasn't, or something like that. Anyway, we need two chips here. So I actually think I'm going to solder this one back on, because I don't think there's anything wrong with that. It's got a question mark on it. Yeah, so we'll start by soldering that one back on, and I've got some brand new ones here. I'll show you the part number of those in a minute. 16 nanoseconds. Yeah, that one on as well, so we've got both those, but at the same time I'm going to remove these. I'll start by removing these. These are just for parity. We're not going to be using it on Amiga. Yeah, there's no point in them being on there. They're just consuming more power, and you know what, those could fix something else at some point. They're obviously going to be smaller than these ones, I think. And of course, if you're going to change a SIMM, you probably need to remove one of these resistors here. It might be that end one, just to identify itself properly in a PC that it's got parity. But in the Amiga, it doesn't check the resistors here, the jumpers, effectively. Anyway, let's start by just removing those three. And you could argue, just leave them on, but I don't know, I like to reclaim things where I know they're just never going to be used. Use some hot air and just push them off, basically. I'll rotate it that way around. Yeah, so I don't envisage this being easy, to be honest. Just move the Amiga motherboard out of the way. Just give myself a wee bit more space here. And what I'm going to do is just come in and have a little bit of leverage there. Not a lot, just literally the weight of the tool. Yeah, I am not like super lever in here, there we go. So the pads are good, that's one down. Two to go. What would be really nice on a SIMM like this if they use the same types of chips for the parity, because then you could just fix it using the chips that are on there. I mean, they look the same sort of package, they've got the same number of pins, I think. So that's two off. Final one. So it's Gadget from the future here. I thought I'd just explain a few things while I'm doing that desoldering. And to expand on the annotation you saw a minute ago, that these are 1 bit each. Well, you count 3 chips, so you're like, hang on a minute, 3 bits? Why would we have 3 parity bits? It's a 72-pin SIMM, this. You've got enough RAM chips on there to have 32 bits wide of RAM, and you have 1 parity bit for every 8 bits. So that would be 4 parity bits. And you'll understand why I'm mentioning this now, because obviously we've got 3 chips. You're thinking, there must be a 4th one, surely. That's it. So, no damaged pads. Yeah, you can see that looks alright. Yeah, so even though it's a bit pointless, I'm going to mop up the solder from these pads here. Not following my own advice here and going the way that the pad's shortest on the board. And in theory, I could move the caps under here as well, because you know what? It's not going to need these caps now either, is it? But a little bit of extra decoupling won't cause any problems for sure. Just going to give those one final go. And a gentle clean with some IPA now. There we go, our SIMM is free of its parity. The other interesting thing with this is, obviously you can see, you could convert this SIMM into an 8 meg SIMM, actually. It's just a case of changing a jumper or two here. Obviously fit in all the caps and add all the chips there, so if I got a load more of those chips there, I could make an 8 meg SIMM, which is useful for chip RAM, on a 4000, because they're going to be double-sided SIMMs in order for it to work properly. You can get a 2 meg SIMM, for example, it's probably got 2 meg on one side, and it won't detect 2 meg, it'll give you 1 meg. Whereas if you had a 2 meg SIMM where there's 1 meg on each side, then it will work. Anyway, now we've done that, I'll put these chips out of the way. I'll show you the part numbers on those in a minute. As I said, they're different to the other ones. So these are 60 nanoseconds. I'm not sure you can see the part number there, but there's one chip on here that's a 70, which I find a little bit strange actually. And the fact this is intermittent, I'm wondering if the 70 is causing the problem. Yeah, we've got a 70 there, right in the middle. Anyway, I'm going to fit a brand new 60 sort of inwards here, and then the one with the question mark I'm going to stick on the end, because it's easier to remove one on the end rather than one that's like that. And I think the way I'm going to do this is, because the clearance down the sides of these is near impossible, I'm going to fit it with hot air. So the way I will do that is just get some flux onto the pads here, and then we'll just simply drag the iron across those pads with some solder. Just get a nice little bead-like surface area to them, and we'll do the same with that one down there. So I'm just going to get copious amounts of solder here and do a wee bit of that. Anyway, I'll deal with that cap in a sec. I'll just use some braid to correct that. So a little beads there. Let's just remove the solder that I just got on top of that plumbing cap, because if you have huge amounts of solder sticking up there, the chip is not going to fit on there, is it? Right, anyway, let's now get the chip. It's going to be the exact same orientation as the others, so I just need to just position it. And that really is like totally surface mounted, if I'm honest. There's not even anything exposed to the sides. So you've got to use hot air to solder this on. Anyway, it's sort of on top there now. So let's just sort of start with this side here. If we get to the right point in temperature, it should just pull down a bit. I'm just kind of looking for it moving, really. I think that's it. It kind of looks pretty square, level, flat, etc. Yeah, it's having a peak down the sides. Yeah, that looks like that's on there. So I'll do exactly the same thing with the one that's got a question mark on it here. This is actually the 4000 repaired video. I haven't finished it, but I'm doing this in the middle of it. So anyway, I've removed all the SIMMs that I had on there. Let's get this one in position. It's cooled down enough now. Just like lukewarm here, just a little bit. And I'll switch it on and we'll see what it gives us. I'll point you at the board first, just in case anything goes up in flames. And it hasn't done. We've got video and it's booting. So let's just go into memory. So it's 4 mega fast, test all. In fact, let's just do range. This region's 4 mega fast. Oh, it looks like we fixed it. Now what I didn't do is put that memory with a question mark back on. I actually think that that was the faulty RAM on this board, because this one was faulty, another one was faulty, and I was trying to work out which one to take off to fix the other one, and I think the one with a question mark, I took that off this one, put it on the other one, we still had a RAM fault, so I took it back off, changed it for another one, and then it worked. So I actually think in that first video when I fixed one of these SIMMs, I fixed both of them by removing the faulty one from this one, if that makes sense. But there you go, we fixed it. Yeah, so that was a nice, really easy repair, and a good bit of practice for me at doing surface mount soldering like that. You know, it's kind of like BGA, isn't it? Just eating it up and letting it suck itself onto the pad, so you've got to get just the right amount of solder on there. Yeah, so I just need to just clean around this with a toothbrush, this area here now. And I think what I'll do is just going to have a look online, just see about the jumpers, just to see if we can remove the resistor there that identifies it's got parity, just in case anyone's ever daft enough to try and put that into a PC and wonder why it's giving an error, you know, because it's trying to allocate parity. And it's gone round 5 times already there, there's no issue. The other issue with this though, it's got a 70 nanoseconds chip on it, hasn't it? So that's an interesting one. I guess I really should swap out that 70 for a 60 as well. I mean, that might actually ultimately be why this is intermittent, because if you test this memory on its own like this now, 60 nanoseconds. Having said that, I think you've got to do something with the Ramsey there to use 60 nanoseconds. I don't think it will just boot and go, oh, you've got 60 nanoseconds RAM, let's go with that. I don't think it does that. I think the timings are for 70s or 80s or something as default. I mean, most people would just literally buy another SIMM because they're not especially expensive, are they? They're like £5 or something, 10 quid maybe. But in years to come, they're going to get rarer, more of them are going to die. And you know what? You may have a really unusual SIMM on something, Amiga or Mac or something, where you just can't source a replacement module or something, but you can get another faulty one or something like that, and then this kind of video might just help. I mean, it's all a moot point anyway, because you know what, I wouldn't be surprised if 10 or 20 years in the future you can just like put your faulty part into some sort of machine and it does everything for you. It does all of the removal, the soldering and everything, I don't know. I'll just go and have a look at information on the jumpers actually. When I say jumpers, what I mean is there's a few pins on one side that get detected, you know, whether you've got a high or low there. Just one of those needs removing, I think. But you know what, I really should remove that 70 in the middle there. I think I'm going to do that. And you know what, just thinking about this, count the chips. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's still a chip here for Parity. That's what the 70 is bang in the middle. That explains it. That's why there's a 70 in the middle. So let's remove that. And I guarantee you, we'll test it again and it's going to work without it, but it just means we've reclaimed yet another chip off this. It's strange though, isn't it? I've got 60 nanoseconds ones on there, and then that one's a 70. You'd expect the Parity to need to be the same speed. Otherwise it's a bit pointless, isn't it? If your Parity can't keep up with the speed of the other RAM chips, it kind of makes a bit of a mockery of having Parity on there at all. Do you see what I mean? And again, I don't know, I was going to say that maybe that's something to do with it being why it's this was intermittent, but I don't think so. I think we've worked it out. It's probably that one with a question mark on it is probably the intermittent one. So place your bets. Do you think it's still going to work without this chip? Or do you think we're going to have to get 60 back on? Not sure if I lost a pad there. No, I didn't. So that's that off. I'll try that cool it a little bit, and then I'll use the braid again. It's like how little can you leave on a SIMM before it breaks? I know what you're thinking. You think you should take them caps off as well. I can't reclaim those. I mean, see, my understanding of Parity could be wrong, and it might not need to be as fast as the other chips. So there might not be anything technically wrong with having a 70 nanoseconds Parity. I guess I should check the speed of those other ones actually, the three we removed. What speed are those? Yeah, those are 70s as well. Part number is different again, so the different types of chips. I'm not sure, but anyway, let's try that now without that middle chip on. Place your bets. What do you think's going to happen? I'm going to say it's going to work. Of course, if we remove any more chips from there, it's definitely not going to work. Let's just see, is it going to boot? Yeah, it's booting from floppy. Memory. 4 meg still, look. Let's test the 4 meg. Would you look at that? It's still working. So see the link down below to the website I'm looking at here. It's a really good article actually. And you can see different tables here that sort of show the common types of 72 pin SIMM. You can see the pin out there at the top. But as we scroll down, you've got the different tables that show, you know, SIMMs that have got Parity, ones that haven't, ones that have got ECC. And most importantly, those 4 configuration bits that are on the end of the SIMM there that dictate whether you want a jump there to presumably ground, I think it is, but it might be VCC, that identify to the host computer what kind of SIMM is in. You know, what speed it is, whether it's Parity or not, and the size. Right, for what I can see, pin 67 and 68 should have a bridge there only to, is it VCC? I'm not sure, or ground. So we've got 3 resistors on there, and there might be 0 ohm links or something. So 67, 68, and the other one we can just remove. That's 72, 71, 70, so 67 and 68, so these 2. It's the 4th one on that side, which is the 4th one here, goes to the inner of these two here. It goes to that one, it comes up, goes there, it's that one. So the right hand one just needs to come off, and that should identify it as 60 nanoseconds, 4 meg modulable without parity. Not that it's important for the Amiga. Hang on, let's just get a bit of solder on there. But I figure if we're doing this mod, let's just do it properly. That's it. Oh. She's a bit of braid on there. And then I'm going to stick it in the ultrasonic actually, just to deal with all the bits of flux and stuff. I really hate this braid. I had some really good braid that someone got me. I may have bought it from Amazon, I don't know, it was like some decent stuff anyway. What I'll do, I'm going to stick that in the ultrasonic now. Right, the SIMM is in there, no heat, switch it on. Right, that'll do, it's been in long enough. Doesn't really need more than about a minute, to be honest. So there we go, 60 nanoseconds, 4 meg SIMM repaired and deparitied. And of course we've got 4 chips that were removed here. And actually all 4 of these are the same size as each other. They're all 42100-70s. Whereas the new ones I feared, you know, that we replaced that were missing, these are different. These are 42400-60s. Anyway, I can put those on my spares now. I'll put the one with the question mark in there as well. Maybe there's nothing wrong with that, I honestly do not know, but that could have been, as I said earlier, could have been the original fault with this particular SIMM. So the only difference here now is it's not got that resistor on, but the Amiga doesn't check those anyway, so it would be very unusual if this now didn't work as a result of removing that or cleaning it up. Yeah, 4 meg again. We'll test the 4 meg first. So what do we mean by parity? For every byte, every 8 bits, we have 1 parity bit. So if I just draw 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 bits there making up a byte. We have 1 parity bit. Yeah, so I'll just put a circle. Our parity bit's going to go in there. So on a SIMM like this, it's 32-bit. You can have 4 bytes. You'll have 4 parity bits. So with 1 parity bit, we can only have a 0 or 1. And I think the most basic form of parity checking is a count of the even number or odd number of bits there. So, you know, we've got 1, 2, 3, 4. We've got an even number of bits, so we would set the parity bit as a 1. The idea being that if high-speed particle, you know, cosmic radiation, it's worth doing a search on that. Do a search for high-speed particles and cosmic radiation. You'd be amazed at what you didn't perhaps know, that stuff that's produced out in space from the sun and perhaps other stars comes through the atmosphere and goes through your RAM chip and changes a bit. It flips a bit. I've always wondered, it could probably do damage as well. I don't know, over a period of time you get enough of those high-speed particles, and I'm not sure it's the same thing actually, high-speed particle and cosmic radiation. I think they're different things, but nevertheless, they might be the same thing. Post down below if you're an expert on that stuff. Yeah, we just want to know whether it's an even or odd number of bits, so that if 1 bit changes state, let's say we get a 1, yeah, high-speed particle or cosmic radiation changes that to a 1, well, when a read is done, and this is the way it does it, when the data is written, the parity bit's set, when you read the data back, the parity's compared. And in this case here, it'd be like 1, 2, 3, 4, 5. We've now got an odd number of bits. That should be a 0. And the system will go parity error. It'll stop processing. You know, it'll just halt in its tracks, come say parity error, and you have to reboot. And if you've not got hardware failure, then obviously it'll boot up and everything's good, and you can try and pick up where you were, but you'll have lost your work. But the whole idea behind parity was for pretty important stuff, you know, like scientific research, I don't know, critical systems where, you know, imagine a bank account. Imagine you've got some code running through your PC, yeah, and you've got a bank account number of a transfer you're about to do, and a bit here changes. And that bit relates to someone, you know, an account number of a payment you're about to make. You could end up, you know, if it didn't have this check, you'll end up thinking everything's alright, you click submit or something, and you've just transferred money into the wrong bank account via a bit of cosmic radiation. And of course the next step up is ECC, error correction something. I forget what the extra C is. Yeah, an error correction just takes this a step further. Instead of 1 parity bit, you may have, 2, 4 or more. I think typically it's something like a byte for every 32 bits or something like that, or a byte for every 64 bits actually. And there, what they do there is use hashing algorithms, things like XOR, do an XOR on, I don't know, groups of bits on first 4 bits and store that, and then the next 4 bits and store that, and then store the XOR of those 2 lots against each other. And you can start to, with a low number of bits, by the time you do XOR, and you get smaller and smaller down, you get to the point where you can, from, I don't know, 3 or more bits, you can understand more or less how to reverse to get back to your original bit pattern. But obviously there's computational time required to do something like that, or cost. I mean, obviously it can be pretty quick to do it if you get the right hardware in place, but there's a cost associated with it. And, like I say, this scenario here with Parity would just cover a single bit flipping. So, straight away you're thinking, there's a bit of a flaw there. What happens if you get 2 of those little rays changing 2 bits at once? Well, it's going to pass the parity check, and it still could go to someone's incorrect account. You can make a payment to the wrong account, etc. But apparently someone's done the maths, the statistics of these rays, and it's like for 90% of the chances there, a single parity bit is enough. So, there's a 10% chance you could get 2 bits flipping, which is still an issue, and that's why ECC came out. And I'm sure ECC, again, is not absolutely perfect, but it's a lot better. Because the other thing as well is what happens if your parity bit changes. This is the thing. Yeah, you could get a false parity error just by this, the parity chip being hit. Yeah, but you still want to know that, don't you? Because if that's been hit by a cosmic ray or something, a radiation, you don't know where it is, so you still want the system to stop. But that can cause you a problem that if 2 bits did, you got that 10% chance where one of these bits has changed, but also the parity bit's changed, everything's good. The system's like, keep going, keep processing, and you send your money to the wrong bank account. Anyway, we're not dealing with bank accounts in this video. It's, obviously gaming based, retro gaming, etc. So yeah, Amigas don't use parity, but PCs, yeah, this is a PC, it's not got any parity, but obviously PCs, they tended to use parity quite a bit for, important applications for, businesses, technology, military, aviation, so many different things like that, where it's pretty critical that, the last thing you want is a bit flipping stay in some memory somewhere. So that is exactly what is going on here. These are 1 bit each, probably the same size as the original ones, I think, but just a bit each. Anyway, I'm cleaning them up just so I can stick them in with my spares. I'm probably never ever going to use those. So I just tested that for about an hour and it passed every single time. So I marked it up 4 meg and fixed 2023.